Hey, welcome to our chord pattern. So today we will be looking at the depth first search, okay, and depth first search pattern. So in which we will be solving some of the problem, discussing how can we use the depth first search. Let's see. First of all, last time we discussed about the breadth first search. In the breadth first search, if you remember, let me show you this. If you remember, in the breadth first search, we were searching the tree uh, 1, 2, 3, 4, 5, 6, 7 level wise. So suppose this is the first level, this is the second level, this is the third level. So we are first of all we were just traversing from the first level, then we were traversing from the second level, then we were traversing from the third level. So in this way we were getting array if we store it at the same time 1 2 3 4 5 6 7. Okay. Now in depth first search, what we will be doing, we will be traversing the tree. First of all, we move to the depth itself instead of moving to the next in the same level. So suppose we are at the level 1, so now we will move to the depth. It can be in the right or it can be in the left, doesn't matter. We Let me start in the right. So I'll move to the right. First of all, I move to 3, then I'll move to 7. Now nothing is there. So I'll move back to the 3, then move to the 3, 6. So it will like 1, 3, 7, 6, and then move back to the 1 and then traverse 2, then traverse 5, then move back to 4. So this is our traversal. Okay, so in this traversal, we will be going inside the depth until we find the leaf node and then moving back and then again going to the other side of that particular node. That is the depth first search. So we will be going inside a depth first and then we'll see. Okay, so this is the problems it solves is pre-order traversal, in-order traversal, and post-order traversal. What are those, by the way? So if you say that, what are those? So I can tell you, maybe I can help with that. So post-order traversal means you are traversing okay, pre-order traversal. Pre-order traversal means you will be traversing the node first, or you doing operation first and then moving ahead. Okay, what are the situations that can occur when we are traversing depth first search? Okay, let's see. What you can do. Suppose you reach to the node. This node, you have the node. What you can do? You can traverse left, traverse right, and then do operations on node. That is the one way. Or you can do, suppose you have the node, then traverse right, do ops, traverse left, and then next, if you have node, then you do operations first, then traverse right, and then traverse left. These are the three cases. Those might happen. Suppose you are here, so you want to add something, so you will add this one first. Or you, if you are searching, so you search first, okay, it is one is present or not, and then move ahead. So that is the pre-order traversal. Let's move to that. So okay, first of all, I searched it. Okay, looked at one, then move ahead. I looked at two, and then move ahead, looked at 4, then it will move back because nothing is there, then it will goes to the right. looked at 5, and then move back, then 3, 6, and then 7. This is the first pre-order traversal. Now let's look into the post-order traversal. Post-order traversal, I will just checking that at the last. So move to this, move to this. Okay, 4 because nothing is there in the child, so I'll traversing it. Then move to this, and then 5, and then 2. Again, this is the post-order traversal and pre-order traversal. And the in-order traversal. Okay, now I got it. And how to solve them? To store the stack, to remember that like at which node we are, we will be using stack. Okay, so how we're going to use that stack? Let's see. Suppose you have this stack and you are at the node 1. We will write a loop for while loop that will run until stack is not empty. Okay, now it is not empty because we have this. We remove it. Okay, pop it, and then we will make it current stock barabar stack dot pop. So now it is empty. For a momentary it is empty, right? But but we can now, it depend on which traversal we are using out of 3. Let's see, we are using in order traversal. So what I'll do, I'll push the next node. Okay, I'll push the okay, wait. So here I'll push the 2 here. Yeah, push the 2 here and push the 3 here because it is an in order traversal, so I don't do this. Sorry. So I push 2 and then operations, and then push 3, right? Now I pushed 3 2 there and did my operations, and then pushed 3, and the operation was suppose printing, so I printed 1 here, and then next is we got the 2, it going to be removed. Okay, then 3 move to the bottom, and then we already push 2. We already pushed. Okay, now we push the 4, we print the 2, and then we push the 5, and then move ahead. Then again we get the 5, we get the 5, right? But it shouldn't be 5, it should be 4. Okay, cool. So stack we will be using, or another way is the function we will be using. So we call 2, call 3 recursively, and then it happens. We will solve the questions and then we'll see actual में क्या होता है. Okay, cool. Let's move to the question then. Yeah, sure, why not? So here is our first problem. In this problem, what is happening? Given a root of binary tree and an integer as return true if the tree has a path from root to leaf such that the sum of all the node values of that path equals to s, otherwise return false. So suppose we have given 10, then we will look for any of the leaf node which have a path to the root such that the sum equals to it. If it is there, then that means it will become true, else it is false. So here we are doing the same thing. So we have created a uh, traverse recursive method in which we will be having a root 0 as a sum that we will be checking, and this sum is equals to the target actually. So here we have the method. So look how we are solving it. Sorry, I just got into the okay. Let me show you what is the problem and how we can solve it. The problem is pretty simple. You have a tree. एक दो एक दो तीन चार एक पाँच आठ सात ओके. Suppose s equals to 9. So we need to find any of the child, any of the leaf node from which to the path to the root node root node such that the sum becomes a 9. So if you add these sum up 1, 2, 3, 5, 8 and then 8, 16. No, this root is not works, right? So this root is not working at all. And then we can look for another root. Yeah. So this root is not working. Then we can see 1, 2, 5, and 7. Then 1, 3, 8, and no. This is also not working. Then this is 5 not working. Then you will look for this 1 or 2 and 3, 5 or 4, 9. Yeah. So this is our path. That is our destiny. So if it is there, that is true. If it is not there, then false. Suppose it was 13, then there is no such a path that have the sum as 9. So how we will going to solve it? Okay, cool. So what is the idea behind the solution is it's pretty simple though. Let me clean a bit. The idea is pretty clear. The idea says we will start from the one, and then we create a sum, and that will be like if it we are at one, so the sum will become one, and we will check if it is right or not. Then we will move to the next in the depth itself. So that is 2. Then we'll increase the sum. Then sum will become 3. Now we'll match it. No. Then we'll go. Okay, we don't match it actually. Sorry. Yeah, that is the wrong part. We won't match it. We go to the depth more and then see. Okay, yeah, it's okay. Yeah. Now the sum become 8. Then we all goes in the depth. Then sum become 10. Then in any condition when the both of the child of this node are empty, then we will check it. Okay, and then if it is not some, then we return false and then move back and then check with this. So that is the same thing I implemented here. So if you see, if the root node itself is not present, then we'll return false. And we are increasing the sum or adding the sum into the root wall. And then if the left and right both are empty, then we are checking key is target equals to the sum, and then return that. If it is there, then true. Is not there, then false. And suppose it is a mid of anyone, mid node, then what we'll need to do, first we are traversing in the left. If true present in the left array, then great. If it is not present, then we are saying or check the right node. And yeah, that's it, done. If you submit it, it is working. Okay, cool. Let's move to the next problem. So here is the next problem. Given a binary tree and a number as, find all paths from root to leaf such that the sum of all the nodes values of each path equals to s. Okay. Given a binary tree and number s, find all paths from root to leaf such that the sum of all the node values of each path equals to s. Okay, equals to s. Okay, sorry, paths we will need to find. Okay, go. We'll not do that. No problem. Output will become 174192. You know? Okay, no problem. No problem. So, okay, how we will going to do that? Okay, moving here. Hmm, moving here. If you see this. Earlier what what did it is the lagbhag same problem, right? It is mostly the same problem. Now we need to remember the path also. That's more only the change here. Other than that, there is nothing happens. So what I will do, um, we need to check if the true if if path exists, right? If path exists, sorry. Mhm. So there are many ways to do it, I guess. Yeah. Let's increase the complex. Let's do it within a simpler manner. What I'll do is, I'll create a result array also. Result array that we will pass, and if I find the zero in it, hmm, then we will say, okay, right, this is the one. You can do in the forward manner or backward manner. Backward manner is good because we will be knowing certainly that yes, this is our zeroth place, right? So let's trying to do. What I'll do is we will create a function traversal नाम का जिसमें we have root, number, and the result array, and then we'll do the same thing as earlier doing, but the one change will if we find a node where number equals to 0, then what we will do, we will create a result array. We will add one more sub array, um, one more sub array named as pushing the root value. Okay, and then if we are moving back, then we will be adding all of them in this array, right? And in the forward way we also do it. What we will going to do is, we will have a result array. Okay, inside this array we will have one array that will be the last one. Or maybe the first one, doesn't matter. Okay, it is the first one, and as soon as we go ahead, we'll be adding the root into it, the values of it, like 1 add कर दिया, 2 add कर दिया, 5 add कर दिया, 7 add कर दिया. And as and when we are moving out of the function, then we will be removing it. 7 remove कर दिया, 5 remove कर दिया. 2 remove कर दिया and then again A1 add कर दिया 13. So this will be our flexible array, you might say. And as and when we find some values or that we will push here, mark them as frozen and or something, right? So this is what we'll do. Let's see this problem. So here is the solution for this. We have this traversal inside which we have root, sum, and all paths. So what we will be doing is if the root is null or sum is less than 0, then we'll be returning false because we don't care. And then if all paths, okay, actually what I'm doing with these paths that I need to tell you exactly. Okay, so if you are seeing this, right. Let me follow first. If you are looking at into it, let me clean it this up a bit. So what I'm doing is mm, I am creating a all path like this, and suppose I reach to the root node, and then what I'll do, I'll add that inside this path without thinking at all. Okay, I have created a one array inside it. You can say it a traversal array or something. You can create it separately or inside it, doesn't matter. But for sake of now, I just created inside it. Okay. So maybe we can create it outside. Let's create it outside. So we have some other array that is the traversal array that will hold all of the that will hold all the parent or ancestors of that particular root. So I reach one, I add one here, okay, and I will move to the depth of it, and then add two here. Then I do the five, and then add five there. This is the result by the five there, and then I reach the end of the okay. Suppose five is end five, and then I reach to the seven. So now, because 7 is the leaf node, I will be checking. Another thing is I will be removing the sum. Like initially sum was 9. So what I'll do is I'll remove from 1, 2, 5, 7 this way. So if the sum becomes 0 at when at the leaf node, that means this is the one. But this is not the one. If 1 and 2, 3, 5, 8. Okay, let's make it 1 so I can save it, right? Okay, now it will become 1. So what I'll do, I'll clone it and save inside it. 1, 2, 5, 7. And as and when I'm going out of this function, going out from this node, what I'll do, I'll remove it also. Yeah. So this was 1. So what I'll do, I'll remove it from it. That is popping. And then I'm at the 5, there is nothing child, then what I'll do, I'll remove it this one. So I again reach to this one. Okay, now the parent is this one. So I will see, okay, 2. So I add 2, then say there is no child and the sum is not becoming 0. So I'll remove the 2, move back to the 2, and then move back to 1, remove 2 again. So this is the procedure we are using. And yeah, let me modify the code a bit. So it uses the two arrays, um, like array call it array. Right, we don't need then this thing, we don't need array. Yeah, this thing अपन push करेंगे, array dot push, value push कर दी, then उसके अलावा I will do this thing. Sorry, I will be pushing this thing inside all pass dot. So all path mein I will be pushing the clone of this array, and that's it. If you run it, something is reading push cannot propagate. All paths. No, I think I can read it. Yeah. Runtime cannot read properties of undefined reading push. Undefined. Oh, array is not defined anywhere. So let's define it here. Let array barabar empty array. Maybe you can just pass it here. We do not need to define it anyway. Yeah, let's run it. Yeah, because here I'm not passing the array. Pass it here and then pass it here also. Okay. Array 0 is not iterable. Where I'm trying to iterate it. Push. Oh, pop यहाँ पे करना है instead of there. Right. All pass some left right node. एरे में पुश कर दिया, सम में रूट वैल्यू डाल सब्ट्रैक्ट कर दी. Oh, regarding it, array 0 is not iterable. Oh, array 0 is not iterable, so it will be array only. Yeah, now it should work. Okay, cool. So now you will be seeing the same thing we did. So we have the array, we have the all paths, then sum and then root. We are removing the value from the sum, we are pushing the value in the array. If the left and right are not present and then sum becomes 0, what we'll do is all path में push कर देंगे array का clone. And this dot traverse and then this dot pop. This is what we are doing. Okay, cool. Move to the next question now. So here is our new next problem. This problem again, just put it here. So here is our next problem. Given a binary tree where each node can only have a digit 0 to 9 value, each root to leaf path will represent a number. Find the total sum of all the numbers representing by the paths. Let's see what the question is saying and how can we solve it, right? Yes. So suppose there is a tree. Okay, this one, and it has the digits in each of the node. That is the value of it. That can be goes to 0 to 9 only. So it might have 1, 3, 0, 5, 8, 7, 3, 2. Okay. Now we need to find all the numbers, all the sum of all the numbers, and each path to leaf represents one number actually. So each path, for this path the number is 130, for this path the number is 135, for this path number is 1873 plus, and for this path number is 1872, and we need to find the sum of these numbers. That is our target. So now, earlier what we were doing to recursive, we were doing it recursively. This time we will be using a stack. Okay. Yes, we will be using a stack to do a recursion. Making it quite complex, but yeah, that's how we will going to do this one. We have a stack, and now we need to figure out what are the numbers are, what we can do. Looks pretty awesome. Like earlier we did, we will have an array in which I'll push 1, 3, and 0, and and what I'll do, as soon as I reach to the leaf node, I will be creating that number out of them. Maybe we can directly um, join them, right? Or maybe we create a number by looking at from the backward and then multiply by 10, 10, 10, and then adding them, like multiply 0 as a 1, multiply 3 as a 10, multiply 1 as a 100, and then sum it. That will become 130. That also we can do. We can do, like, we can create number any way, any of the means that we want, but that we can do, right? So now we have this number. What we can do is, we store that number somewhere, or maybe we can just add into the sum, total sum. That was the solution if we were doing it as an recursively, like, or here if I doing it and similarly it is going to happen. But yeah, what how we will going to do in the stack, using the stack. So here we will have, maybe we can say result, that will be empty, and here we will say total sum will 0. Now we will say stack will have one at the initial state. Yeah. While current, and the current equals to 1. Okay. One node, and current is not current और नॉट स्टैक एम्प्टी। इनमें से अगर दोनों ही एम्प्टी नहीं है, दोनों या तो स्टैक में कुछ नहीं है या फिर करंट में कुछ नहीं है, तब जाके तक ये वाइल लूप चलेगा। ठीक है, सो वी आर हियर राइट नाउ, व्हाट वी वांट टू डू इज we want to move to the next, definitely. So what I'll do, I'll move to the next of at the end जब तक कि मैं पहुंच नहीं जाऊँ। So what I'll do is current, while current is not none, तब तक I'll do current बराबर current dot left, right? While current dot next is not null, current dot left is not null, तब तक मैं करूँगा। अगर इसका left null है, then I don't go यार। So now I'll reach 3, then I'll reach 0. So I'm here, and then what I'll do, if it is there, if it is some value, then I'll push it to the result, right? Leaf node में पहुंच गए। It's quite complicated, but this is how we will do something. Let me finish it, then I will discuss it. Okay, let me implement it first. So here is the solution. Still using the recursion. Yeah, because I tried with the stack, it was a bit complicated. So I thought, let's go with the recursion. Okay, what I'm doing here is, okay, let me show you that. Why it reconnect always, I don't know. Oh, whatever. So suppose we have an array 1, 2, 1, 3, 4, 5. So this is the tree we have. So I will create an array that will track all ancestor nodes in each level, right? So I'll start from first one. So I'll push 1. I'm here. So push 1. Then I'm here 2. And then push 2. And then I'm here 1, 3. Now I know at the end, if uh, both child or there is no child. No child if no child, so what I'll do, I'll create a number and then return it. Okay. If not root, okay, root, else what I'll do, else simple, I'll call for left and right. Let's see. So now 1, 2, 3. So I'll return a number 1, 2, 1. So I was here, so I returned a number 1, 2, 1. Now, now if it is not child, so it will call for right. Else me what we'll do, we will traverse in left and right. Okay, and if root is null, तो हम return करेंगे 0. Why? Because अगर मैं यहाँ पे हूँ and if I'm going to this child that is already null, so यहाँ पे कोई sum तो होगा नहीं because it's 0, so it will return a 0, and I will add both of them because from this tree I get 0, from this tree I get 121, so the overall sum should be 121 at this point. So I will add the traverse from right, traverse from left को जोड़ देंगे, and that will become our value, else this will become our value. And before before moving away from this method, what I'll do, I'll pop this because this is already used. Now I'm at this level, right? So array dot pop and then return the value. That's what we will do. So similar way I did here also. So if you see the traverse route, if root is 0 array, then value is, if both are if the node child is not present, then we are creating a number here. This is the number creation. This is the number creation, and then if not, then we are left and right को sum कर देंगे and then pop the value and then return the value. And if I submit it, it should work fine. Okay, cool. It's working fine. Cool. Let's move to the next question. So here is our new problem. Given a binary tree and the number sequence, find if the sequence is present as a root to the leaf path in the given tree. So we have given this sequence and the output will calculate. Okay. So here sequence is given 199. Then if it is present in the tree path, that means great, else not great. It looks simple, right? So I will match 1 with the 1. If it is matching, then nothing. Move to the left and right both of them and check if 7 is matching to this 9. So for this one I need to have a index or depth variable, so that can point out at which point, which position in the sequence I should point out. Okay, so we will have a depth variable also. So now 7 is not matching with the 9, then we'll return false, and we'll go here, 9 matching, 2 is not matching, return false, return true, and then done. Cool. Okay, let's build it. So here is the solution for this solution problem. Simple. We having this sequence, we are not having index. What I'll do instead, I'll just slice the sequence and then it will become 9 or 7. Okay, if we are at the root 1 and we are moving to the 9, so I slice the 1, so now at the 9 only 9 will going to be sent. That I'll do. Okay, so if the sequence length is 0, then return false. If the root is not present, the return false. If sequence 0 is, if this like 1 is matching 1, then in that case scenario we will check if this node is leaf node or not. If it is in leaf node and inside the sequence length is 1, then we'll return true. Agar nahi hai, it is a mid node like 9, then what I'll do, लेफ्ट में एंड राइट में विल सेंड द रूट एंड देन सीक्वेंस को स्लाइस कर देंगे, सीक्वेंस को स्लाइस कर देंगे, and if it is not true then we'll return false. Okay, then I'll run it. Okay, cool. So let's move to the next question. Okay, here is the next problem. In this problem what we need to do is, given a binary tree and number s, find all paths in the tree such that the sum of the all nodes value each path equal to s. Pretty simple. We already find the whole path now we just need to find the sum, not a big issue. Okay, cool, we'll do that. See you after implement. Hey, I think I misunderstood the question. The question is not saying ki path from the root, it's saying ki path from any node, right? Yeah, like given a binary tree as, find all the paths in the tree such that the sum of all the nodes values in each path equals to s. Please note that the path can start or end at any node, but all path must follow direction from parent to child. Okay, any okay. So for that I need to figure it out.